Hello again, everybody. Today we're going to begin with the chapter 6, learning about functions and how we use them in our program and how we create functions. So the idea is that as programs get larger and larger, and I know we've only been dealing with small programs, but as programs get larger and larger, it's difficult, if not impossible, to write all of your code within a single uh, main function. So typically what we do is we create smaller components of our programs, and each one of those individual components or units will perform a particular task or complete a particular unit of work. And those little components or parts are what are called functions. Sometimes they're called functions, sometimes they're called methods, so you can kind of use the word interchangeably. I typically call them functions, but oftentimes they're referred to as methods. So if you take a look here, this is out of your book. I think it's like page two. I don't know, it's like 299 or something. The On the left here, where we have main, imagine that this is your main function, which we've. So by the way, too, we've already created function on our own. All of our programs have a main function, and imagine that your program is comprised of a whole bunch of different statements, and each one of these statements might perform a particular unit of work or a grouping of tasks. So the idea is that instead of having one main function, you could break up your program and having a main function and then also other functions, function 2, function 3, and function 4, and each one of them will perform a particular task. And depending upon how the logic is in your program, you may or may not call those functions depending upon the input values that are being fed into your program. So that, in high level, that's what functions are used for. Let's take a look at the syntax for functions, and then go ahead and create some on our own. So before we go ahead and create a function, we have to define the function, and then we can call the function. How we define a function, there's rules for the syntax, and it goes like this. So the first part of a function is what's called the return type. Some of you I've seen have had your main method or your main function defined as returning an integer. Most of you, and this is how I typically do it, use a void return type. So anyway, the thing that goes before the name of the function is what the function is going to return, and that could be any one of the primitive types. It could be void, which is quite common, or void, which means nothing. It's not going to return anything. Or likewise, we could return classes or we could return objects from our functions, but that's for another course. And the next thing that you have is the name of the function. So in this case here, all of our functions were called main, all right, and there was always lowercase m-a-i-n. After the function name is a pair of parentheses, an open and closing parenthesis, and within the parentheses you could have a parameter list, meaning you may or may not pass things to your function in order to complete a particular task. So when we start off today, we're going to create functions that are going to have an empty parameter list. Later on, I'm going to show you how we can pass values to a function. After the final closing parenthesis, you'll have an open curly brace and then a corresponding closing curly brace. The stuff that's in between that pair of curly braces is what's called the function body, and that's where you're going to place the work that you're going to do is within those curly braces. So high level, that's it. So that's how we can declare and that's how we can define and create a function. Let's go ahead and let me show you an example of a simple case where we can create one or two functions, and then I'll show you how we can call the functions from within our main method. So let me flip back here to Visual Studio. All right. The general rule of thumb is, and I'm going to follow this paradigm, is that we're going to create what's called a function prototype. All of our functions will be defined within our function prototypes, which are going to go above our main method. And this is not the only way that you have to do it. However, this is sort of like a standard, and I don't want to confuse you guys right now, so I'm going to try to keep things. I'm going to try to follow one particular format. And in reality, in industry or for more complex programs, you would always have to define your prototype somewhere before your main method. So the way that we declare our prototypes, and again, a prototype is just nothing more than a little agreement as to what the name of the function is and what it's going to do. So I'm going to create two functions. Both of the functions I'm going to create are going to do nothing more other than just display some output to the console, and then later on I'll show you how we can pass parameters to our functions. So I'm just going to create a prototype here. So again, the first thing that you're going to specify is what is the return type of your function. Notice I'm doing everything above my main method here, right? It's important that you do this. So the first thing is going to be the return type of my function, and then I'm going to specify the name of my function. So the first one I'm just going to call this, I'll call this function A. Function A. Open and closing parameter. Open and closing parentheses. This function is not going to take any parameters. Semicolon, and then we're done. So that tells the compiler that there is a function defined as function A that doesn't take any parameters. Now we're free to go ahead and call that function within our main method, but we still need to create the body of our function. So let me create another function prototype for function B. Void B. Again, no parameters, and now we're done. Now what I'm going to do is this is typically how you do this. Up top on lines 4 and 5 is where I have my prototypes. These are guys that this is what's called my function header. Okay, so this stuff here is what's called the function header. Now I'm going to provide the function implementation for function A and function B below. So here, void function A. Okay. And this is where I'm going to provide the body of my function. And as I mentioned before, all I'm going to do here is just dump something to the console, just so you guys can see how this works. Inside function A. That's the end of my statement. And that's all that function is going to do, is display that stuff to the console, that string to the console. Before I forget, one thing you'll notice up here is after I had my function prototype, I put a semicolon. This is required. Okay, so within your prototypes, okay, you need to provide your function header, and that must be terminated with a semicolon. Down here in your function body, you don't put a semicolon because you have the pair of open and closing curly braces. Wouldn't be a bad idea. Let's put a quick comment here. This is function A. Now let me create function B. See out inside function A. Oops. And semicolon. And that's the end of function B. I'm going to do a quick comment here. This is function B. All right. Now, in order for me to use functions A or function B, okay, sorry, typo here, function B. In order for me to use function A or function B, I need to do what's referred to as calling or invoke the function. Let me show you how we do this. So let me first display something within main right now. Let's see, main begin. Let me do an end out here quick. All right. Let me build this thing and show you what happens. All right, so my program built. Now if I run this thing, notice what happens here. It just says in to my console, it's just going to say main begin. The reason why that happens, and you might be wondering, well, why am I not seeing this, right? Why am I not seeing this? The reason is because I never called or I never invoked function A or function B. So the idea is that you have access to these functions, but unless you actually call or invoke them, your program will not use those functions. All right, so you can think of function A and function B right now just sitting there as being like optional, and then until I call them, they're just going to be sitting there, taking up space in memory. That's the idea. So the way that you invoke a function is you just give it the function name, function A, open and closing parentheses, and then the semicolon. Okay. Now what's going to happen is once main kicks off, line 8 will execute. Then execution comes down to line 9. Line 9 says, okay, here's function A being invoked or called. Let me jump to that function. That function is down here on line 13. Program execution will begin on line 14, comes to the end on line 15. Once function A is complete, execution then comes back up to main, and whatever statements are after function A will then be executed. So here I'm just going to say cout back. Let's do this to be consistent. Main end. All right. So now that's going to be the end of my main method. And you know what? Just to make this a little bit easier on the eyes, let me put a tab character in there just so that you can might be a little bit easier to see within the console. So another thing to mention too is that you can think of function A as being nested within inside of main, because once main executes, main is sort of like at the adder level. Then we jump into function A. Function A does something, and then we return from function A back into main at the top level, and then we complete our main method. So let's run this guy and let's see what happens. Let me clean this up a little bit. I should have put some endls in here. Endl. That looks better. Am I missing any more? I think that's good. All right. So here's what happened. All right. So main kicks off. We display line 8. Get down to line 9. Line 9 invokes function A. Execution jumps down to line 14. Lines 14, 15, and 16 execute. Once that's done, we return back to function. We return back to main, and then we complete what's left in main, and it's just a display of main end. Another term that you'll see later on, if any of you guys are computer science majors, however many of you are, you're going to come across the concept of what's called a stack, and the idea is that each one of these functions is being put on the stack, and that's sort of how, actually, that is how the execution of these functions are being completed. All right, so we're not limited to just calling one function. Okay, I can call another function, and let's call function B. Function B, open and closing parenthesis. Now what's going to happen is main kicks off. We're going to execute function 9. We're going to execute function A, which is on line 9. Once function A is done, we're going to jump back up into main. The next statement after function A is going to be called, and in this case here I'm going to say main, let's do this, cout, say back in main after function A. Let me just get rid of this just to confuse you guys. So back in main after function A, let me copy this down, and then here after B. All right. So I think this, sort of chronologically shows you what's happening within our program. So again, we start at main, invoke function A, jump into A, do whatever A is going to do, come back into main, execute line 10, come down to line 11, invoke function B. Function B is down here. Function B does whatever unit of work it needs to do. We come back up to our main method, come back to line 12, execute line 12, execute line 13, and that's the end of our program. So again, this is about as simple as you can get, and the whole idea is that we're able to break up our program into different modules or units of work or functions or methods, whatever you want to think of them as, and each one of them has a responsibility for a particular task. In the next section, or maybe it's the next section coming up, I'll show you how we can actually do more meaningful things. But I think if you can just at least understand how functions are created and how we use them, I think we'll be in good shape here. So what happens here, right? So this is my output. So we begin in main, we jump into A, come back into main, jump into B, come back into main, and then finally finish main, and that's the end of our program. Rarely are our functions rarely are your functions going to be as simple as just displaying something to the console. More often than not, you will have a function that is going to accept some type of data, and you're going to perform some task on that data. In order for us to get data into our function, we need to send that data into our function via what are called parameters. And we've actually already done something like this. If you remember back earlier on in the course, we learned how to use the POW, the pow function, which is takes a number and raises it to a particular power, and it will return that value from the function. So in this case here, when we call the pow function, we passed it 2 arguments, and it will return a value to us. Inside what the function is doing, we really don't know, nor do we really care. We just know that it's going to perform a particular task and return a result to us. So in order for us to do something similar to this on our own, meaning like we want to create our own custom functions, we need to provide a list of parameters to our function. Okay, and if you look at this little example that they have down here, here's a function that the author put together. It's called display value. So the name of the function is called display value. The return type is void, and it takes a single parameter of type integer called num. That means that when this function display value is invoked, the programmer must pass an integer to this function, and then we'll get a copy of that variable copied into the variable that's called num. Then within the body of the function can do whatever it needs to with num, and in this case here it's just displaying what the value is of num. So let me go ahead and create a little function that will do something similar to this, and it's going to take a list of parameters. So let me jump back into our program over here, and I'm going to create another function that's going to be of type void, and I'm just going to call this I'll call it display sum. Right. So the function name is going to be called display sum. It's still a void function, meaning it's not going to return anything. We're going to learn about that next time around. And now I need to tell the compiler what it can expect to see. What I'm going to enforce what the function is going to have to accept when it's going to get called by specifying a list of parameters. So display sum is going to do nothing more than take 2 integers, add them together, and display the results of the console. So what I need to do is within my function prototype, I need to specify what the parameter types are. So my first parameter type in this case here is going to be an int, comma, and another int. So it's going to be 2 parameters, and then my semicolon for the end of my prototype. That means that whenever display sum is called, you have to pass it 2 integers. If you don't, the compiler will complain and your program won't build. So let me go down here, and now that I have my prototype in place, let me go ahead and create the implementation. All right, so I have function A, function B. Down below function B, again, you never implement functions within another function, their own standalone unit of code, so that need to be outside the declaration of any other function. Right, so this is going to this. Let's throw a little comment in here. This will add to ints and display the sum. All right. Now what I need to do is I need to specify the definition of my function here with the same name that I had up in my declaration up above. So it's called display. Was it sum? Name needs, so display sum. Here you need to specify what is the parameter type. Once again, you must give it the parameter a variable name. So I'll call this num1, comma, the parameter type once again, and once again another name, a distinct name for the variable that's going to be passed in. And you always do your open and closing curly braces, and now you're within the body of your function. So this is in your prototype. Let me scroll up real quick. In your prototype, you just specify the parameter types. In your function implementation, you must specify the parameter types along with a valid parameter name. And this follows the same rules as any other type of variable naming convention. Again, it needs to start with a letter or an underscore, and then you could have a number afterwards. So it's the same rules as before. So display sum is going to do nothing more than add up num1 and num2 and display the results of the console. So let me do this a little bit more verbose than probably necessary. So let me create a local variable here that's called total. And that's going to be equal to the value of num1 plus num2. Right? So num1 plus num2 will be added together and assigned to the variable that's called total. Now I'm just going to display the total to the screen. Right? So the sum of num1 plus num2 equals total. All right. So here in my cout statement, I'm just going to display sum of, and then it's going to display the value of num1 plus num2 equals the value of whatever total it is. All right, here's the idea. You might be wondering, why would I bother even doing something like this? It's just 2 lines of code. Imagine that within your program you need to do this many times, all in different parts of your program, not just within main. So what you would do is you would have display sum called from anywhere within your program, whether it's in main or within another function. Okay, because a function can call other functions just as main does. And if this bit of work is something that is done repeatedly over and over and over again, that's a good candidate for something that should be stored within a function, because then you can just put your logic all in one place, do your work there, and then whoever wants to use that function can do so without having to worry about all the details. So now let me go back up at the main here. Let me kill this stuff. All right. Well, I'll keep this part here: main begin and main end. All right. So now what I'm going to do is I want to invoke the display sum function. All right. So what I need to do is call display sum, and now you'll see, like with the IntelliSense, that's just cool. Even throws the comments in there. That's something new. This tells you that we need to provide it with 2 integers separated by a comma. So here I'll just pass in 10, comma 20, semicolon, done. All right. So once execution hits line number 10, we will jump down into here into the display sum function. The values of 10 will be copied into this parameter. The value of 20 will be copied into this parameter, which are just local variables. We then take the value of num1 plus the value of num2, add them together, stick it in total, and we display the result. So this is how we're going to invoke display sum. Control F5, and you'll see, right, it just says the sum of 10 plus 20 is equal to 30. Now that's not the only way that I can call display sum. I could have a local variable here. I'll call it int x is equal to 5, y is equal to let's do something. I'll try using different numbers, 30. All right, so I have some local variables, x and y. I could call display sum passing in x and y. Okay, so they don't need to be hard-coded values. Is what I'm trying to say. So they just need to be these things, right? Here we're telling the compiler we're going to pass 2 ints, so you just need to pass the 2 ints. Okay, whether they're literals or they're variables, it will satisfy the compiler, meaning that they're both integers. So let me go ahead and build this thing, and now we should see display sum will be invoked twice. All right, passing in 10 and 20 the first time, and then 5 and 30 the second time around. Okay, so that's how display sum works. And again, if this is a piece of work that your programmer needs to do over and over and over and over again, well, if you have to program, not necessarily just within main, that's the reason why you would want to put this bit of work inside of a function. Another thing I want to mention before we move on is that when we want to pass values to a function, okay, we just pass a value. We don't specify the type. What I mean by that is here, okay, when I want to pass the value assigned to the variable x, we just pass x. We don't do this. Okay, if we do, the compiler will complain, probably because it's going to try to think it's a redefinition of a variable. Okay, type name. So the idea is that when we call a function, just pass the value or the variable. Don't specify the type. If you do, as I've done here, the compiler will complain. So even if I fix this, right, the error will show up over here. So just pass x and y or 10 and 20. Don't specify the type. All right, the last thing that we're going to cover for today is what's called passing data by value, which is what we just did in the previous example with the display sum function. I'm going to dig down into a little bit deeper just to kind of explain to you how the values are being passed into your function, because it's an important topic. So the idea is that when an argument is passed into a parameter, only a copy of the argument value is passed. Changes to the parameter do not affect the original argument. The idea is, by the way, let me clarify some wording here that you might see, is that when you are calling a function, the thing that you're passing to the function are called arguments. All right, this is just some terminology. So when you're calling a function, the things that you pass to that function are called arguments. Within your function, when you receive those arguments, within the list of values, okay, those things are called parameters. So again, I don't want you to get confused by this. So just remember, that's how this works. So you can kind of think of them as almost being one and the same. And to be honest with you, I do. It's just technically there's a slight difference between what's considered an argument and a parameter. But regardless, the important part is that what's called a copy of the argument's value is passed. And the author has a good little illustration within the book, and this is like a classical example. All right. So imagine you have a function which passes a argument which has a value of 12, and that 12 could be something that's stored in a variable, or it could be something that's hard-coded within your program. The idea is that when you invoke a function, okay, and you pass 12 as an argument, what is actually going to get copied into the parameter of the receiving function is a copy of the number 12. So you can kind of think of it as them being duplicated. And this is important because what happens is the default behavior within Java and the default behavior within C++ and C and even Java, and to be honest with you, most programming languages, is that parameters are being passed by what's called value. Later on in this chapter, we'll talk about a different way that we can pass parameters by what's called reference. And later on in future sections of this course, of the second part of this course, you'll learn about what's referred to as pointers, which are quite a bit different than passing by value. But just remember this part. What is being passed into your function parameter list, or the values within your parameter, is a copy of the argument. Any changes that you make to that parameter will not be reflected outside of the function. I think now's probably a good time to demonstrate that to you. So let's go back to my program over here, and I'm going to create another function. It's going to be another void function, and I'm going to call it double. What should I call it? Double. I'll call it double variable. All right, and it's going to take. Let's do something different. Let's have it take a double. Now, you know what? For now, for this week, let's just keep everything as ints. Just keep it simple. All right. So keep that as an int. So the idea is that this method, this function that's called double variable, will take an integer and we will double its value and we'll display it to the console. The idea is you pass in 5, it'll display 10. Okay. Let me go down here and let me create the implementation for this. It's called double variable. I'll just quick little comment here. This will double the value of an int and display the result. All right, just a quick little comment. Again, it's a void function and it's called double variable, and it's going to be int, and I'll call it value. Right. By the way, I think I mentioned this before. The function names follow the same rules as variable names, so it needs to begin with a letter or an underscore, and then you can have a number within the function name. But what's more important is that when you declare your function up here in your prototype, that you have the same name down here within your implementation, or your definition is typically referred to as. And if you don't, you'll get some strange errors, and I'll show you that in a little bit. So here's the idea. All right. So let me do this in 2 steps. So I'll say int double val is equal to value times 2. Right? So I have a local variable that's called double val. It's going to take whatever the value is being passed in as the parameter, right? So value is a parameter. It's going to take whatever that value is and multiply it times 2 and store the result in a variable that's called double val. Right? And now what I'll do is I'll just display what that is. So let's do this. Let's say value doubled equals double and now. Alright. So here if I pass in 5, right, it's going to become 10. So we can say 5 doubled is equal to 10. So I'm going to do this in 2 steps. A little bit I'm going to change this and show you what pass by value is actually doing behind the scenes. So let me go up here and get rid of this stuff. Well, you know what? Let me keep int x is equal to 5. That I'll use. I'm going to keep that. And now I'm going to call double variable. And I'm going to pass in whatever the value is for x. So if x is equal to 5, I should expect to see 10 displayed on the console. So let's build this and let's see what happens. Okay. 5 doubles is equal to 10. Great. Here's the idea, and this is the key part, is that when we assign 5 to my local variable x, and then we take that local variable x and pass it as an argument to the double variable function. What's happening is a copy of x, okay, is being stored in the parameter down below called value in my function declaration, my function definition. So we take x, we're passing as an argument to double variable. Execution then is going to jump down to line number 33. Okay, a copy of the value of x will be stored in the parameter that's called value. Since it is a copy, any changes I make to this parameter here, value, is local to this function, meaning that they won't be reflected outside of the main, I'm sorry, outside of this function call. So if I'm passing in 5 here, value is equal to 5. 5 times 2 is 10. We store that in double value, and we're done. Imagine I do something like this. Here I have, other stuff. Here goes here, blah, blah, blah. And then somewhere in my program, I do something this way. Say value is equal to, I don't know, itself times 100 or something. Okay. What's going to happen here is you might think that this parameter will be equal to 500 when we're done. Okay. However, since this is a copy of the argument being passed in, whatever changes I make to value are local to this function, and they won't be reflected outside of the function call. So let's demonstrate that. Right? Let's display what the value is of x before we make a call to double variable. So we're going to call this, I'll say x before is equal to x. Right? So before we call double variable, x is going to be equal to 5. I'm going to copy this down, and I'm going to say x after is equal to x. And you might think to yourself, okay, well, if I'm passing in 5, and at the end of the double variable function, I'm taking 5 times 100, well, I would expect that x is now going to be equal to 500. So you might first think that x will be equal to 500 after double variable is called, but it won't be because it's being passed by value. So let me run this. Let's see what we get. Right. So we kick off main. Right. Kick off main. X is equal to 5 before we call the function. Right. 5 doubled. Right. So this is done inside of the function body. Okay. And x is still equal to 5 after we call the double variable function, because the value of x is being passed into a copy of the value of x is being passed to the parameter called value. Any changes that we make to value are local, okay, reflected locally within this function, and they won't be reflected outside of this function. So that's how pass by value works. Definitely, take a read through like these couple sections in the book, just so you can understand a little bit further how how functions work, and what's the logical flow of how functions function, and pay particular attention to how function pass by value works. There are other ways to pass values to functions in C++. And the other two are what are called pass by reference, which we were going to cover on this course. We'll do that next week. And the other one is what's called pass by memory address or pass by pointer, and that's something that we don't cover in this course, but it's covered in covered in the second half of this course. So let me show you a common error that students might make. And this could drive you crazy if you're trying to bug something like this. And let me back up a little bit and explain to you how the compiler and the linker works. And so back probably in the first day of this course, we spoke real quickly about the different parts of the program build. All right, so first we take a source file, it gets compiled, and then it gets compiled into object code. Then the linker takes the multiple object code files, takes all them and shoves them together and creates an executable program. So I'm going to show you guys an example of a common mistake that students make, and it'll generate what's called a linker error, and linker errors can be a nightmare to try to debug. So let's first talk about the compiler. So this stuff here on lines 4 through 7, this stuff is used by the compiler to say, okay, somewhere within this program there's a function called function A, function B, display sum, and double variable, along with their corresponding parameters. This stuff is used by the compiler so that within our program we will allow that we're letting the compiler do its task, which is to enforce the syntax of the language, which tells me that if I call double variable and I pass in a value of x, we're good. If I pass in a value of 5.5, I'm probably going to get some kind of warning because I'm sort of breaking the rules here, okay? And the rule is that double variable takes an integer. What I'm trying to pass as an argument to the double variable function is a double. Right? So I'm going to get some kind of warning, and it says it's warning argument conversion from double to int, possible loss of data. So the compiler will then go ahead and take 5.5 and it'll truncate it to the value of 5. So the compiler will catch that kind of stuff for you, which is good. Let me go back to here and change this back to, I'll just leave it as x. Right? So the compiler will enforce those types of things because it sees that I use different types. What I could do is, why is that squiggly in it? What I could do is I could make a mistake, and remember this is your function prototype. So you're telling the compiler that there's something that's called double variable, taking an int, and then later on down here when I provide the implementation for double variable, I might make a mistake, and let's imagine I leave off the e by mistake, right? So I called it double variable and I forgot the e. Well, my compiler, right, I'm not getting any kind of errors here. So if I try to compile my source file here, right, I'm just going to compile this file. It'll tell me that it succeeded because the compiler is just looking at this kind of like as an agreement. All right, there's a function that's called double variable somewhere. It doesn't necessarily mean that it needs to be within this file. It just needs to be something that the linker can find later on to build against. Commonly, your program will be built upon many parts, and those parts aren't going to all be included within one file. And we've actually already done that type of stuff, because here, like all the stuff within the IOStream library is already all compiled somewhere for you, and when it's necessary for you to use, when it's time for you to use the cout object within your program, the linker will then go ahead and find that stuff and build it all together. So you'll notice that, even though we've used some of the things out of the IOStream library, we don't actually have any of the implementation within our source file. So what happens now is, in this case here, right, I have a function that's called double variable, but I made a spelling mistake down here. So the compiler isn't going to catch that kind of error because it thinks, okay, well, it's not in this file, but it's the linker's responsibility for finding that later on. So again, I compiled that already, and we saw that was successful. Now if I go ahead and try to build my program, or if I try to build my solution, I'm going to get some strange error. And here it's the things that we're going to get. All right. So here it says I have two errors. Actually, there's just one, but it refers to it as two. All right. So here I get linker error 2019. It says unresolved external symbol void underscore cdecal double variable int. And you have this thing that's over here, it's called name mangling, which is how the linker is looking for this. So what's happening is now the linker is trying to find the implementation for a double variable, but it can't find it. So that's what the linker error is for. And more often than not, this is caused from one of two things. You either did something like I just did here, where you have a function prototype not matching the function implementation, right? And this is what's called the function signature, which is the name and the parameters. Or the other one is your project settings need to be modified to reference the proper libraries within your program. We won't be doing anything like that in this class because all the things that we're going to be building are local to our program, so we won't be using any like third-party libraries. But anyway, so that's a common mistake. So if you come across this and you get any of these unresolved external symbols, more often than not, it's just because you have a typo, right? And a typo could be either the function name, okay, or the parameter list here doesn't match the parameter list here, meaning that, here I specified as an int, but down here you use like a double or something, or you change the return type to be an int instead of a void. So just be aware of that. So anyway, so that's a quick intro to functions today. Take a read through these sections in the chapter. Next week we'll cover some different ways that we can pass parameters to functions, and also actually pass arguments to functions, and also how we can return values from functions, which is extremely important. I don't want to cover all that stuff all in one day because we're already hitting 45 minutes here. So anyway, that's it for this week. Bye bye.